This is the study guide for the semester 1. We'll do 2 videos, one for the chapter 2 part and then one for chapter 3. All right, number 1, what is the equation in vertex form of a parabola with a vertex of -1, 8 passes through 1, 0? So, my equation in vertex form is going to be y equals a and then x minus h squared, quantity squared, plus k, right? The vertex, this is going to be my h, this is going to be my k. So I can do y equal, and then x minus -1. Whoops. Okay, x minus -1 plus 8. Okay, which gives me x plus 1 squared plus 8. Okay, I could have at the same time plugged in my point that's on this line. So my point that's on this line is 1, 0. So x is 1 and y is 0. So I'm going to do 0 equals a. And then my x is 1. So 1 plus 1 squared plus 8. So I get 0 equals a. And then 1 plus 1 is 2. And then 2 squared is going to give me 4. So I'm going to write this as 0 equals 4a plus 8. I can subtract 8 from both sides. So I get -8 equals 4a. And when I divide both sides by 4, I get -2 equals a. So now I have all the pieces to write my equation in vertex form. So it's going to be y equals -2. And then it's x plus 1 squared plus 8. And there's my equation in vertex form. All right, if we want to check this, check our answer, we can use the graphing calculator and graph it. So if we put in our equation -2, x plus 1 quantity squared plus 8, and we were to graph it, and we got to zoom out a little here. So zoom out. Okay, we would be able to see our vertex is at 1, 8. Right, our vertex is at 1, 8, and then our point on here, that should be the point 1, 0. Okay, goes to the point 1, 0. Vertex is -1, 8. All right, let's go to number 2. All right, number 2, function g is a transformation of the parent function, x squared. F of x equals x squared. The graph of g is a translation 4 units left, 2 units down of the graph f. Write the equation for g in vertex form. Okay, and then rewrite it in standard form. All right, so here's what we're going to do. F of x equals x squared. Okay, what this really is, right, is 1 times x minus 0 squared plus 0. Okay, so if we want to do g of x, we're not going to shrink or stretch it, so we're going to leave it as a 1, right? So we're going to leave this as a 1. Okay, x minus, right? So we want to go 4 units to the left. So we want to go left 4. So we're going to put that in right here. Okay, so this is our left 4. Okay, and then we want to go down 2. So instead of plus 0, we're going to do -2, which gives me x plus 4 squared minus 2. Right, so that would be in vertex form. X plus 4 squared minus 2. 4 units to the left, so it's minus a negative 4, which becomes plus 4, and down 2, so we put minus 2. All right, they want it now in standard form, so what we're going to do is we're going to do some binomial distribution. So we have x plus 4 twice. So it's going to be x plus 4 times x plus 4 minus 2. So we got to do our foiling. So x times x is going to give me x squared. X times 4 is going to give me 4x. And then 4 times x is 4x. And then 4 times 4 is going to be plus 16. And then we have at the end our minus 2. So we get x squared plus 8x. And then 16 minus 2 is going to be plus 14. Okay, so then that is standard form. So this is vertex form. And then this is standard form. All right, let's look at number 3. All right, number 3, what is the vertex and axis of symmetry of the graph of the function f of x? Okay, so our h of x, h comma k, right, that is our vertex. This is your vertex. Okay, so to find the h, we need to do opposite of b over 2a. So when you have a quadratic or a function here in standard form, we need to do opposite of b over 2a to find the h. And then we substitute that back in for x to find the k. All right, so in this case, our a is going to be 1, our b is going to be 6, and our c is going to be 9. Okay, so I'm going to have h equals negative 6 over 2 times 1, which means my h is going to be equal to negative 3. All right, to find the k, we need to substitute in negative 3 for x. So we're going to find f of negative 3. So that's going to be equal to negative 3 squared plus 6 times negative 3. Okay, and then plus 9. So you can put this all in your calculator at once if you would like. But that's going to be 9 minus 18 plus 9 is going to give us 0. Okay, so my vertex here is going to be negative 3 comma 0. And then my axis of symmetry is going to be x equals negative 3. Right, your axis of symmetry is always x equals h. Right, that's my axis of symmetry. Okay, so if we wanted to graph it, just to check, right? We hit tab here, we go up. We had x to the x squared. What was it? Plus 6x plus 9. Okay, so my vertex right here is at negative 3, 0, which is what we said. And my axis of symmetry is this vertical line. This is my axis of symmetry, negative 3. This is the line x equals negative 3. All the x values on this line are at negative 3. All right, let's go to number 4. Okay, describe the transformation of the parent function f of x equals x squared. So we have a vertical stretch of 2. This is a vertical stretch. Okay, we are moving right 4. Because remember, it's x minus h, right? This is x minus 0 squared plus 0. Right, so we're going from 1 to 2. That's a vertical stretch. It would be a vertical shrink if it was less than 1. Okay, we're going right 0 on this one, and this one we're going right 4. Right 4. Okay, and then we are going down 8 units. Okay. Identify the vertex and the axis symmetry. So our vertex then is going to be 4, -8. Right? H is 4. So this is my vertex. Again, it's +4 because remember the formula is x minus h. Right? Your vertex form is A, and then it's x minus h squared plus k. So my k here is -8. My h is +4. All right, and then axis of symmetry is just going to be x equals 4. All right, we could graph it just to double check, right? So 2 x minus 4 squared plus 8. You can see we've shifted 4 to the right and 8 up, right? If we graph our original as well, x squared. We've shifted 4 to the right and 8 up. And it's also, it goes up at a faster rate, right? This blue one goes up at a faster rate. It's a vertical stretch of 2. Okay, it's going up faster than the other one is. Number 5. Okay, rewrite the expression in factored form. Okay, so on this one, you can just use your standard x method because a is 1, right? It's 1x squared. If it was like 2x squared or 3x squared, you wouldn't be able to do that. But this one, we can just use our traditional x method. So we need two numbers that multiply to 12 and add to 7. Okay, our possibilities, right, are the factors of 12. So we could do 1 times 12. We could do -1 times -12. We could do 2 times 6. We could do -2 times -6. We could do 3 times 4. Or -3 times -4. In this case, we wanted to add the 7, so it's going to be 3 and 4. So we're going to have x plus 3. And then x plus 4. Right, if you go backwards, x times x is x squared. X times 4 is 4x. 3 times x is 3x. 3x plus 4x is 7x. And then 3 times 4 gives us 12. So we know this is a pretty good answer. Okay, number 6. Rewrite the expression in factored form. So this one, we aren't able to use our traditional x method. We're going to have to do factor by grouping. So what we're going to do is we're going to do a times c, which is -6. So we're going to have two numbers that multiply to -6 and add to -5. That's going to be -6 and +1. And what we're going to do is we're going to split this middle term up into -6x and +x. So we're going to do 2x squared minus 6x plus 1x minus 3. And now we can factor by grouping. So if we're looking at 2x squared minus 6x, so remember 2x squared, that's really 2 times x. And then minus 6 is really 2 times 3 times x. So what we have in common is a 2x. Right, so we both have 2x in common, which leaves us x minus 3. Okay, and then over here, they don't have anything but a 1 in common, so I'm going to factor out a 1. And then this is just x minus 3. Right? If you look at x and 3, we really could do 1 times x minus 3 times 1. So they have the 1 in common. So then you have x minus 3 left. Now they both have an x minus 3 in common, so we're going to factor out x minus 3. And then what we have left is 2x plus 1. Okay, if we work backwards, we would get 2x third plus x minus 6x, and then minus 3. And when we combine those, we're going to come back to negative 5x. So we're good. Okay, we're good. All right, let's go down to 7 and 8, where we're doing the same thing, except this time we need to solve. All right, so we need to solve. So we need to move everything to one side, so that's equal to 0. So I'm going to subtract 9 on both sides. So I get 5x squared plus 12x. I'm going to do minus 9 minus 9. So I get minus 9 equals 0. Okay, subtracting 9 on both sides. Okay, now I can't use my traditional X method, so I'm going to have to do the factor by grouping. If you want to factor using the box method, that's fine. I'm going to do A times C. So that's going to be negative 45. And then I need it to add to 12. So I need two numbers that add to 12, but multiply to negative 45. It looks like it's going to be 15 and negative 3. 15 times negative 3, right? So negative 45. Let's see, we would have 1 times 45. One of these has to be negative. So 1 times negative 45. You could do negative 5 times 9, or negative 9 times 5. And then negative 3 times 15, or 3 times negative 15. And so we're doing this one. Okay, so we're going to split up that middle term. You have 5x squared plus 15x minus 3 minus 9 equals 0, minus 3x. Okay, the first two terms, what they have in common is 5x. So when we factor out the 5x, we're left with 5x, or x plus 3. Again, if we need to see that on the side, what we have is 5 times x plus 5 times 3 times x minus 3 times x minus 3 times 3. So for the first two, we're factoring out a 5x. And we're left with x plus 3. Okay, for the other ones, we're going to factor out a negative 3. And we're going to be left with x plus 3. So we're going to factor out a negative 3, and we're left with x plus 3. All right, they both have an x plus 3 in common. And then what we have left when we factor out x plus 3 is 5x minus 3. Okay, to solve, then we need to set each of these equal to 0. So we need to do x plus 3 equals 0. And 5x minus 3 equals 0. Subtract 3 on both sides, so we get x equals 3. Add 3 on both sides, so we get 5x equals 3. And then divide both sides by 5, and we get 3 over 5. Those would be my two zeros. All right, number 8. Doing the same thing. Okay, we need to move everything to one side. So I'm going to have 6x squared minus 5x minus 6 equals 0. All right, we need to subtract 5x from both sides, and we need to subtract 6 from both sides. Okay, we need two numbers that multiply to a times c. A is 6, c is negative 6, so that needs to be negative 36. And we need two numbers that add to negative 5. All right, so 36, let's see, you could do 1 times 36, negative 1 times 36, 1 times negative 36. You could do 2 times 18. So 2 times negative 18. You could do 3 times 12. You could do 4 times 9. You could do 6 times 6, negative 6 and 6. Okay, we're going to do positive 4 and negative 9. Okay, that's going to multiply to negative 36, and it's going to add to negative 5. Okay, we're going to split the middle term up. So I'm going to do 6x squared plus 4x minus 9x minus 6 equals 0. So 6 is going to be 3 times 2 times x plus 2 times 2 times x minus 3 times.
Still in the building, report to the main office. Police Abubakar. If you're still in the building, report to the main office.
Okay, so really if we factor everything, this is what it's going to look like. 3 times 2 times x, that's 6x squared. 2 times 2 times x is 4x. Minus 3 times x, and then minus 3 times 2. So for the first two, right, what we have is a 2 and an x. So we're going to factor out 2x. And what we have left is 3x plus 2. For the second ones, we're going to factor out a negative 3. And what we have left is 3x plus 2. So then they both have a 3x plus 2. And then we have 2x minus 3. Perfect. And now we need to set each of these equal to 0 and then solve. So 3x plus 2 equals 0. And then 2x minus 3 equals 0. So we're going to get 3x equals negative 2 when we subtract 2 from both sides. And then divide by 3, we get x equals negative 2 over 3. We add 3 to both sides, you get 2x equals 3. Divide by 2, we get 3 halves. Okay, perfect, perfect. Those are our two solutions. All right, number 9. Okay, square root of negative 100. So the square root of 100, right, is really plus or minus 10. So the square root of negative 100 is plus or minus 10i. Okay, square root of 16 is 4, so the square root of negative 16 is 4i, really plus or minus 4i. And the square root of negative 49 is plus or minus 7i. Okay, it's plus or minus because if I take 10i and I square it, I'm going to get 100 I squared. We know I squared is negative 1. That's going to be negative 100. If I take negative 10i and I square it, I'm going to get 100 still, I squared, which is still going to give me negative 100. So the square root of negative 100, it could be 10i or it could be negative 10i. Same thing with the rest. Okay, number 10. We are solving. So I need to get x by itself. So I'm going to subtract 25 on both sides. X equals negative 25. X squared equals negative 25. To get rid of a square, I have to do the inverse, which is a square root. So we get x equals plus or minus 5i. Right? Square root of 25 is 5. So square root of negative 25 is plus or minus 5i. Okay, number 11 and 12, we are adding. So when you're adding, you can just get rid of the parentheses. Really, there's a 1 out here. So if you distribute, it's going to be 1 times 9 is 9. 1 times 2i is negative 2i. Okay, there's really a 1 in front of here. So when you distribute it, you get plus 6 and then minus 7i. So really, when you're adding, you can just ignore the parentheses. You don't need them. Okay, combine like terms. This is going to be 15 minus 9i. Remember, we write complex numbers in the form a plus bi. So our form is already good. A is 15, b is negative 9. All right, let's look at 12. Okay, we're going to simplify here. So again, imagine a 1 out front. You get 2 plus 3i. This one, though, would be negative 1. So when we distribute it, you're going to get minus 4 and then plus 9i, which is going to give us negative 2 plus 12i when we combine like terms. All right, number 13 and 14 are multiplication. Okay, so we're going to FOIL and distribute just like we did with binomials. 5 times 5 is 25. 5 times 2i is 10i. Negative 2 times 5 is negative 10i. And then negative 2i times positive 2i is minus 4i squared. Okay, if we do 10i minus 10i, those are going to cancel, and we're going to get 25 minus 4i squared. We know that I squared is equal to negative 1. So this is going to be 25 minus 4 times negative 1. Negative 4 times negative 1 is going to give me a plus 4, which is going to give me a final solution here of 29. All right, 14, we distribute. 8 times 5 is 40. 8 times negative 3i is minus 24i. 15i, and then minus 9i squared. Okay, for I squared, again, I squared is equal to negative 1. So I'm going to do 40. I'm going to combine like terms. This is going to be minus 9i. Right, negative 24 plus 15 is negative 9i. Minus 9i squared. So instead of I squared, I'm going to substitute in negative 1, which means I have 40 minus 9i plus 9, which gives me 49 minus 9i. All right, the next 4 questions have to do with the quadratic formula. 14 and 15 want us to solve using the quadratic formula. So in order to use the quadratic formula, we need everything to be equal to 0. So we have to add 2x and 2 to the other side. So it's going to end up being x squared plus 2x plus 2 equals 0, right? We have to add 2x to both sides. We have to add 2 to both sides. So now we get a equals 1, b equals 2, and c equals 2 as well. So we're using that quadratic formula. So it's going to be opposite of b plus or minus square root b squared minus 4ac all over 2a. So it's x equals. Okay, so for us in this particular situation, we're going to get negative 2 plus or minus 2 squared minus 4 times 1 times 2 all over 2 times 1. Okay, 2 squared is 4. All right, put all of this right here in your calculator at once would be fine, but you should get 4 minus 8, which is negative 4. So we get x equals negative 2 plus or minus the square root of 4 minus 8, which is negative 4. So it should be negative 4 over 2. All right, so that's going to give me negative 2 plus or minus 2i over 2. Right, square root of 4 is 2, so the square root of negative 4 is 2i. I need to divide both of these by 2, right? So it's negative 2 over 2 plus or minus 2i over 2, which is going to give me negative 1 plus or minus I. Okay, so my two solutions are going to be x equals negative 1 plus I and x equals negative 1 minus I. Um, 16. Okay, same thing. We need to move everything to one side, so I need to subtract 8x from both sides. So I get 5x squared minus 8x minus 4 equals 0. So in this case, a is going to be 5, b is going to equal negative 8, and then c is going to be negative 4. Okay, so I have x equals opposite of b plus or minus b squared minus 4ac all over 2a. So we get negative 8 plus or minus negative 8 squared minus 4 times 5 times negative 4 all over 2 times 5. All right, so there's our numbers plugged into or substituted into the quadratic formula. That's going to give us positive 8 out here, plus or minus the square root. This is 64, right? You can put all of this in your calculator at once. That would be awesome. But 64 plus 80, which is going to be 144, all over 2 times 5, which is 10. So 144 is a perfect square. So it's going to be 8 plus or minus 12 all over 10, right? The square root of 144 is 12. So we're going to have two solutions here. I'm going to have x equals 8 plus 12 over 10, which is going to give me 20 over 10, which is going to give me an answer of 2. And then the other one is 8 minus 12 over 10, which is going to give me negative 4 over 10, which if I reduce that is going to give me negative 2 over 5. All right, 17 and 18 are just using the discriminant. Yeah, do this. All right, so the discriminant is just the b squared minus 4ac here. It's this part. If I could circle it well, right here. Okay, so if b squared minus 4ac is greater than 0, then you're going to have two real solutions. If b squared minus 4ac equals 0, you're going to have one real solution. And if b squared minus 4ac is less than 0, then you're going to have two complex solutions, right? And the reason they're complex solutions is because if you have a negative under the radical, you're going to end up with an imaginary number, right? If you have a positive number under the radical, you're going to end up with the positive version of it and the negative version. That's why there's two real. If you only have one real, you're going to end up with 0 underneath. So the plus or minus 0 is going to go away because it doesn't matter if it's plus 0 or minus 0. And so you have one real solution. But if it's negative, you're going to end up with a negative under the radical, which means an imaginary number. Okay, so this one really is 5x squared plus 0x plus 14 equals 0. Okay, so A is 5, B is 0, C equals 14. So all we need to do is b squared minus 4ac. So that's going to be 0 squared minus 4 times 5 times 14. 4 times 5 times 14 is going to give us negative 280. Since 280 is less than 0, this is going to be two complex solutions. Okay, two complex solutions. All right, the next one. Basically the same thing. Okay, so on this one, A is going to be 25. B is going to be negative 20. And C is going to be 4. So our discriminant is going to be b squared minus 4ac. So it's going to be negative 20 squared minus 4 times 25 times 4. Okay, so that's going to be 400 minus 400, which is going to be 0. So b squared minus 4ac is going to be 0, which means we have one real solution. One real solution. All right, perfect. Okay, number 19 and 20. We can do this by using substitution, or we can just use our calculators. So let's use our calculators. So I'm going to put in the two functions. So the first one is 1/2 something x squared. Perfect. The second one is y equals x minus 4. Okay, and we can see that there is no solution, right? These don't intersect anywhere. There is a complex solution, but there's going to be no real solution here. Okay, no real solution. So for this one, we can put no real solution. No real solution. There is a solution, it's just not real. So this really should say find the real solution. And then we should say there is no real solution, even though there really is a solution in the complex plane. Okay, the other way you could do this is substitution, right? They're both equal to y, so you could have also done 1/2 x squared equals x minus 4. If you multiply everything by 2, you're going to get x squared equals 2x minus 8. You move everything to one side, we get x squared minus 2x plus 8. Okay, you can't factor this, so you'd have to try and use the quadratic formula. So we get -2 plus or minus square root -2 squared minus 4ac, which is going to be 1 times 8. All over 2a. So we would have 2 plus or minus square root. This would be 4 minus 30. This would be -28 over 2. So this right here is going to give you complex solutions. Okay, which means that there are no real solutions. Okay. All right. Number 20. So again, let's just put it in the calculator. 3x squared minus 2x. So 3x squared minus 2x minus 1. Enter. There's our parabola. Okay, and then the second one is 1/2 x. I believe it was plus 5, right? Yep. Okay, so to find our solutions, we would have to do menu, analyze graph, intersection. Click to the right, to the left, there's one intersection. So -1.06, comma 4.47. Okay, and then we can do menu, analyze graph, intersection, because we have another solution over here. And that's going to be 1.89, comma 5.95. Okay. Which are the two answers. Okay, right here. Again, if you want to use substitution, you could have, right? We could have said 3x squared minus 2x minus 1 equals 1/2 x plus 5. Okay, I would multiply everything by 2, so I'd get 6x squared minus 4x minus 2 equals x plus 10. Move everything to one side, so we'd have 6x squared minus 5x minus 12. Okay, we could try to factor. It would be hard. We'd have to end up using your quadratic formula. It would be 5 plus or minus 25 minus what, 4 times 6 times negative 12, right? And then this would give you solution. Okay, so just use the calculator is fine for that one. Okay, that's the end of the topic 2 part of the review. We'll do a second video for topic 3.